Howdy, folks. Hopefully, we were able to get a look at tension in the string yesterday. If not, then make sure you take a little bit of time just to kind of see what that stuff looks like so that when we start to talk about Atwoods here or Atwood devices here, um, they get a little bit easier for you to understand what we're looking at and why we're looking at it that way. Okay? So, we're going to start off just real kind of um, nice and basic here for us. All right? So, before we start Atwood's machines, what we want to do is we want to make sure that we feel comfortable with understanding forces from a net force standpoint and acceleration from F equals ma, Newton's second law. Okay, so here's what we start off with. Okay, if we see a 300 Newton force being applied on the left side of this box, and we see a 200 Newton force being applied on the right side of this box, the question becomes, all right, what will be our net force, right? So as we look at this, what is the unbalanced force acting on the crate, all right? And then if the crate has a mass of 50 kilograms, what will be its acceleration? So what we see here is these two forces, the 300 and the 200, are acting in opposite directions. Because they're acting in opposite directions, the bigger force should win, so to speak. So what that means for us is we should see that here our Fun is 100 newtons to the right? Because we see that 300 newtons acting that way, that has 100 newtons more force, so that thing's going to make all of this push to the right, okay? So now if we see that our Fun is 100 newtons, right, and we know that Fun equals ma, right? So we know that that 100 is going to go in our Fun. The 50 is going to go in our mass. So what we end up seeing here is 100 equals 50, sorry, times A. 100 divided by 50 should get us 2 meters per second per second. Okay? So it just shows us that, hey, we can calculate this thing. This thing's going to be going 2 meters per second after 1 second, 4 meters per second after 2, 6, 8, 10, 12, so on and so forth throughout the whole thing. Okay? All right, so now put a little rocket on there. Okay? So if the rocket produces 3,000 newtons of force, and there is a 500 newtons of resistance, friction, air resistance, everything else you want to talk about there, what is the Fun acting on the rocket box system? So what we have is we have 3,000 newtons going that way, right? Now, the resistance, again, like we talked about last chapter, are 500 newtons here. Now, that's not going to be going with the rocket. It is actually going to try and slow down or stop the rocket, right? So we say, okay, what's the Fun acting upon this? And then if the rocket has a mass of 50 kilograms and the box has a mass of 75 kilograms, what will the acceleration of it be when the rocket is ignited? Okay, well, all right. So if we got 3,000 forward, 500 backwards, like we just saw back here, right? Because those two are going opposite directions, we should see these two should cancel out, or the 500 should go away from the 3,000, and we get a 2,500 Newton force working to the right, forward, whichever way you want to describe that, right? So if the rocket has a mass of 50 kilograms and the box has a mass of 75, that's going to be 125 for us, right? So then our M here equals the mass of those two, the 125 kilograms. All right. So once we know that, okay, this is our Fun up on the top here. That's our mass there. Remember, Fun equals ma. 2,500 divided by 125 gives us 20 meters per second squared. Okay, so this thing is going to go forward at 24 to 60, 80 miles or meters per second as we go forward. All right, hopefully we're doing okay there. All right, so now we change it up a little bit. We tie to the back of this a box that has a 25 kilogram mass. All right, so now what we're seeing is we still have 3,000 newtons here, right? Going forward, all right? But now, between these two, between box 1 and box 2, we've got 625 newtons. Now, because it's resisting it, that's going the opposite direction of the motion, right? When we see these two, because they're going opposite directions, which one should win? The rocket should win, right? How much should it win by? Well, it should win by 2,350. That's 3,000 minus 650. So now if we know that our fun up here is equal to 2,350 newtons, right? The masses of these two together, our mass total is going to be 100 kilograms, right? For the two boxes, plus another 50 for the rocket. Our overall mass is going to be 150. Sorry, folks, I'm out of practice with doing my Khan Academy stuff here, right? Because we've got 25, 75, 50. We should have 150 kilograms of total mass there, right? So then we take our 2350. Let me just make sure I verify that. 2350 divided by 150. Yep, it's 15 with the 6 repeating behind it. Okay. Because all three of those are getting moved with that force, with this force up here, all three of those are going to experience that acceleration. Right? Last one. Now we put a rocket going the other way. Okay. So now that we look at this one, all right. So the second rocket has a mass of 25. We can find out our total mass based off of all of those different masses. So we see this is 3,000, right? Our resistance is still 650. So we got 650 newtons of resistance. That thing is going to the left. This one, the 3,000 newtons, is going to the right. Now, this other little rocket on here, guess what it's doing? It's also kicking one, right? So what we see is 500 newtons is going to go that way, right? So when we look at this, we've got a bunch of different forces. Now, let me break it apart for you, okay? Well, let me take it here and look at it this way, all right? The first rocket produces that force to the right, like we showed. The resistance is going to be to the left. And the second rocket pushes that thing to the left. So, because in this case what we're seeing here is our unbalanced force is all about the combination of all of these forces, what we're going to see is that this is the rocket one, which is pushing right. We're going to see the resistance pushing left, and we're going to see rocket 2 pushing left, right? So what we end up seeing is those are going opposite of the big one, right? Now, again, if you were to say, hey, the 50 kilogram rocket, I want that to be negative. It's going to the right. I don't like right. Okay, that's fine. Then your overall fun would just be negative because you don't have enough to balance that out. So when we see this is 3,000 minus 650 minus 500. Right? That's where we get the 1850 from. Okay? The B part then. Well, we're going to use Newton's second law, right? So if we're going to use Newton's second law, that's fun equals ma, we need our total mass, right? So we got 125 from the front part. That's our 50, right? And our 75, right? So that's the front box. The back box is 25. The back rocket is another 25. So what we see is when we add those all together, that ends up being our 175 there. So all four of those are going to experience that 1,850 Newton thrust. Okay? So once we do that, that's where our 10.57 comes from. All right? Now, to use this for kind of our applications, we're going to use this when we talk about Atwood machines with two hanging masses. Okay? Now, you can read up on George Atwood. He really just kind of was a person who, um, had this device, and it was really kind of crazy how he was able to use it to actually confirm the acceleration of gravity. If you want to look that more up, go for it. It's kind of interesting. Okay? So if we look at this, right? So we've got these two masses now. Both these masses are going to try to be pulled down, right? So the amount of force on the 3 kilogram is going to be 3 times 9.8. Now, I made it absolute value so that it's all positive numbers, just because positive numbers are easy for a lot of people. You could still keep it negative. Negative just means that's that direction, right? 5 times the 9.8 over here gives us our 49 right there. All right, so here's the question for you. Ready? Which one of those two is going to win? Well, you should be saying the 49, right? So the 49, because it wins, because it has more force, because it's heavier, should cause something kind of interesting to happen. Now, working with pulleys allows us to redirect these forces. So as this force goes up into this pulley, right at this point here, it's actually pulling on that pulley that way with 49. Same thing here. This 29.4 creeps up into there, and it's really trying to pull that way. So it's just like the rocket, just like the box, just like the rocket and the box on the other side. Now what we're seeing is this thing's getting 49 newtons of that way, right? This is getting 29.4 of that way. The one that should win, all right, the mass that will cause movement is, ding, 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 this one. So what does that mean? This one should go what direction? If it's going to be the heavier one, it should go down. Now notice that this string is connected all the way over to here. Does that mean that the 3 kilogram one goes down as well? No, that means that's going to go up. All right, means it has to go that way. We're going to get that pivot, that whole turn. Okay, so we ask, what's the fun? All right, unbalanced force in this case is just the difference between those two, 19.6 newtons. What's the acceleration? Well, if we know the fun, both of these things are going to experience that movement. So what we start to see here is 19.6 is going to equal 8 times 8. All right? Once we divide those two out, what we see is our A is equal to 2.45 meters per second squared. All right? So those are Atwoods. Check your email. You probably already have it. We'll probably start throwing homework at you and stuff like that so that you can start working through that and start to get a sense of that. I'll also start to get an idea or a better idea for you of when I want to do some quizzes coming up and maybe some labs and stuff like that. All right. Hopefully Atwoods wasn't too much for you right now, and hopefully you feel pretty comfortable about it. All right. Let me know if you got questions or let me know if stuff doesn't make sense. Otherwise, have a great day. Okay. Talk to you.